For example 1, we're going to look at 4 basic transformations. Each of these is going to move the graph left, right, up, or down. So if we start with A, we have y is equal to f of x minus 3. And the question is, does this change my x values or my y values? Since this minus 3 is outside of the function, it's going to change the y value. Anytime you change an x value, you would change what's happening inside the function. But since there is no change there, this is only changing the y values. In fact, it's going to subtract 3 from every single y value. So if we write down the points on the graph, we have -1, 0, we have 0, 1, and we have 2, 1. These are the 3 main points on the graph. If I know where these 3 points go, I know where the entire graph goes. Now this minus 3 means we're subtracting 3 from every y value, so the points actually become quite simple. These 3 change by subtracting what's happening in place of y. So this is going to be -1, -3. The next one's going to be 0, -2. And this last one is going to be 2, -2. So I'm just going to plot those on the graph and then sketch the entire picture around it. So let's see. We have -1, -3. That's here. We have 0, -2. And 2, -2. So I took the 3 points on the graph and they all dropped down 3 places. So the entire graph does this. And here we have a graph of f of x minus 3. Now if we compare this to part B, if we have y is equal to f of x plus 4, same question. I mean, am I changing the x values, the y values? If I look at this function, nothing is happening to this x. The only thing that's happening is outside the function. So this is only changing the y values. And in fact, we're adding 4 to every single y value. So I could list the points out again, do this whole process over, but instead, why don't we just go to the graph, the original graph, and look at each y value and just increase it by 4. So starting with, let's say, this point at -1, 0. If you go up 4 places, it's going to go to -1, 4. If you do this for every other point on the graph, you'll have your complete picture. So for example, 0, 1, adding 4 to the y value goes to 0, 5. Then the last point here, 2, 1, goes up to 2, 5. I connect the dots, and I have my picture. So no real surprise here. What's going on is if you subtract a number to the y value, it goes down, in fact, 3. And if you add a number, it's going to go, in this case, up 4. So pretty simple. Unfortunately, if you look at C and D, here's where things get a little bit confusing. So let's start with C. That is y is equal to, and it's f of x minus 3 this time. The way this is written, there's nothing outside of the function. Everything that's changed in this function is within the parentheses. So this actually changes the x value. That's the only thing that changes, just the x value of the original graph. And you would think that would go to the left 3 places if you were guessing. But anytime we change an x value, it's always going to have the opposite effect of what you would expect. I'll just write it out, but this is actually going to go not left 3 places, but it's going to go right 3 places. I'll use one of the points to, maybe describe why this is true. Maybe we could focus on the point on the original graph of -1, 0. Keep in mind that we are changing the x value, -1. Said another way, -1, 0 is the same thing as saying f of -1 equals 0. If you go back to the original function and change the x to an x minus 3, what you're asking is, what number do I put in place of x? in order to make the thing inside the parentheses equal -1. So I'll go back down here to list that out, but if you want f of -1, but you have x minus 3, what number would you put inside the function for x? And it's going to be y is equal to f of 2 minus 3, because when you simplify that, it becomes f of -1, which is 0. So that's how the x changes. It was -1, but now it's 2. So I'll draw that on here. What happens is the whole graph goes 3 places to the right. So now if you look at the point, if we go back to the point 0, 1, and this point goes 3 places to the right, it ends up here. You can actually just count over. And likewise, the point that's at 2, 1, if this goes 3 places to the right, it's going to end up at 5, 1. And if I connect these, this is the graph that I get. So this graph seemed like it was going to go left 3 places. Actually, it goes right 3 places. And if this holds true for part D, you have f of x plus 4. Again, you might think this would go right, but anytime you're changing just an x value, so just the x value changes, this isn't going to go right. It's actually going to go left 4. So I'll go back to my original graph, take each point, and just move it 4 places to the left. So let's see. The -1 goes to -5. Maybe I'll make that blue. -5. The one that's at 0, 1 would go to -4, 1. And then the one that's located at 2, 1 goes to -2, 1. And this is our graph. So this example is good because it shows the 4 different cases. If you're changing a y, it's going to go exactly the way you think it would. However, if you change just an x, it's going to be the opposite. For example 2, a and b have multiple things that are changing the function. So if we start with a, we have y is equal to f of x minus 3 plus 4. In this function, we're changing the x's, but we're also changing the y's as well. From example 1, I know x minus 3, it's not going to go left 3, it's actually going to go right 3 places. But since the y is plus 4, and it acts the way I expect it to, it's going to go up 4 places. So if that makes sense, you really can just go to the original graph and perform this, make it go right 3 and up 4. And in terms of order of operation, this is the order in which it would move. You would work inside the parentheses first, and then outside the parentheses last. So this is what I'll do. I'll go to my original graph and move each point 3 places right, and then up 4 places. So if we start with 2, 1, if it goes right 3, it's 5, 1, and then it'll go up 4 to 5, 5, which is right here. So that was, it went 3 places this way and up 4 places this way. I'm just going to do that for the remaining points on my graph. So here is 0, 1. So it is going to go, let's see, starting here, it's going to go 1, 2, 3 places this way, and then up 4. So we end up at 3, 5. And then my last point that I'll check is at -1, 0. So it'll go over 3, and up 4, we end up at 2, 4. Since the entire graph moves this way, that's my final equation. Now if we do the same thing for b, that is y is equal to, and we have 2f of x plus 4. Now something different happens in this example. I know that we're changing the x's, and since it's this plus 4, okay, I know it's actually going to be left 4 places. Now this 2, it's outside the function and it changes the y values, but this isn't a plus 2 or a minus 2, this is multiplication by 2. So what this is going to do is what you'd expect, since we're changing the y's, it's going to double the y values. So let's see if we can reason this out. So I'll start with my original graph. So I'll look at, let's start with this point here, -1, 0. So it's going to go 4 places to the left. Now the y value is 0 here. So if you double it, you're multiplying 0 by 2. So it actually doesn't go up or down, it stays right where it is. So we get 5, 0. I'll do this with the remaining points. So let's see. If we look at the point 0, 1, again, it's going to first go 4 places to the left. Now the y value is 1, so if I double it, it's going to go up to 2. So I'm going to end up with -4, comma, 2. And for the last point, same thing happens. We're at 2, 1, so I'll end up at -2, but when we double the y value, it goes up to +2. So we get -2, 2. So this is the picture that I have. So it resembles the function that I started with. It is definitely 4 places to the left, but now it's been stretched. The fact that we multiplied every y value by 2 meant the one that was at 0 stayed where it was, and the others moved further away from the x-axis. So we can actually refer to this as a stretch. And that's it.